since the vertical component is given b sin theta, single formula in different forms. That's all. Rotated with a uniform speed of 3000 rotate. See again, so simple. There is nothing here to calculate much, but this substitution, which means the loop is placed inside a solenoid on its axis. Very important. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my today's session, we will continue solving problems on electromagnetic induction and wind up with this session. I hope all of you have practiced problems from the previous sessions. Practice, practice, and practice is what is called precision. The first one, quite interesting. The problem says a coil of wire of 6,000 turns. There is a coil of wire of 6,000 turns and mean area 0.5 meter square. Area of the coil is 0.5 meter square. It is rotated. Rotation. The coil is rotated with a uniform speed of 3000 rotations per minute. Come see, 3000 rotations per minute, not seconds, in a space where the magnetic flux density is 1 into 10 power minus 4 Tesla. The axis of rotation being perpendicular to the field. ನಾನು ಈಗಾಗಲೇ ಹೇಳಿರೋ ಹಾಗೆ, the first part of any solution is to collect the data. I just write the data here. First I have number of turns n, which is 6,000. So 6,000 turns of wire. So number of turns is 6,000 and area 0.5 meter square. So here area equals 0.5 meter square. And uniform speed of 3000 rotations per minute. So frequency is 3000 divided by 60. So this is 50 rotations per second. 3000 rotations per minute na rotations per second convert madidini. I have divided by 60. So 50 rotations per second. And magnetic field strength is 1 into 10 power minus 4 Tesla. Now, the first thing I have to calculate is the maximum value of induced EMF. Maximum value na E naught ant baradvi N A B omega. So the maximum value of induced EMF E naught is N A B omega. So the first one is E naught, which is N A B omega. Or this is number of turns 6,000, 0.5 into 1 into 10 power minus 4. Now omega can be written as, very good, 2 pi f. If you remember our theory, this omega is nothing but 2 pi f. So this is 2 pi into 50. So on simplification now, this is equal to 6,000 into 0.5 into 1 into 2 into 3.14 into 50. So on simplification, this turns out to be 94.2 volts. So in simple calculations, we have got the maximum value of EMF as 94.2 volts. Next, what has to be calculated? Average value. All of us know E average is nothing but 2 by pi times E naught. So 2 by pi times 94.2. So this turns out to be 2 divided by 3.14 into 94.2. So the answer is 59, nearly 60 volts. So E average. So you need to know this expression. As I told, if the concepts are clear, substitution is very easy and the simplification is still easy. Third one, we need E RMS value. So E RMS is nothing but E naught by, 2 by pi times. So this is E naught by root 2. Again, 94 divided by 1.44. So the answer is 0.2 divided by 1.44. So it is 65.41 volts. And the last one that has to be calculated, the EMF in the coil. Just substitute T is 0.021. You will arrive at the answer. So, see, very easily, the question may appear to be a lengthy question, but part by part, when I solve, it is very much easier. But preferably, I need to know the concepts. Next one. A long solenoid with 15 turns per centimeter. 15 turns per centimeter andre this is 1500 turns per meter. So 15 turns per centimeter, which is 1500 turns per meter, has a small loop of area 2 centimeter square. Area of the loop is 2 centimeter square. Placed inside normal to the axis of the solenoid, which means the loop is placed inside a solenoid on its axis. Very important keyword to solve the problem, axis of the solenoid. If the current carried by the solenoid, changes from 2 ampere to 4 ampere. Current is now increasing 2 ampere to 4 ampere in 0.1 second. What is the induced voltage in the loop? Gamansili, a long solenoid with 1500 turns per meter length. That 1500 turns per meter andre per meter length, turns per unit length ant karitivalva. Here small n is given, which is capital N by L, directly is 1500 per meter. It has an area of 2 centimeters square. So area is 2 into 10 power minus 4 meter square. SI system convert ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. 2 centimeter square is 2 into 10 power minus 4 meter square. Current changes from 2 ampere to 4 ampere, which means change in current DI is 4 minus 2, which is equal to 2 ampere in a time interval of 0.1 seconds. Now in this case, how do I find the induced voltage? Very simple, as we have done in the previous problems, previous sessions. Phi or E is d phi by dt. From Faraday's law, the induced EMF equals d phi by dt. I am just taking the magnitude. But now, with respect to the data given, number of turns per unit length, area of the loop, change in current, how do I express flux? So E equals D. We know flux is B into A divided by dt. If you are thorough with these sessions, these bit of informations really help to solve the problems. Flux is represented as vector B dot vector A, or this is A dB by dt. Now, what is this B? How will I link that B with the question given? That is where I told, he says, axis of the solenoid. Do I know any expression for magnetic field on the axis of a solenoid? And that can be written as EMF E is equal to A d by dt of mu naught N into I. The magnetic field on the axis of a solenoid is mu naught N into I. Or this therefore is A mu naught into N di by dt. Simple rearrangement of terms, rearrangement of expressions. Or this is equal to mu naught is 4 pi into 10 power minus 7. Area was 2 centimeters square. So this is 2 into 10 power minus 4. So this is 1500 into 2 by 0.1, 20, which means this is equal to, on simplification, 7.5 into 10 power minus 6 volts. See again, so simple. There is nothing here to calculate much, but this substitution with respect to concepts have to be clear. Third one, current in a circuit falls from 5 ampere to 0 ampere. Current flowing in a circuit reduces from 5 ampere to 0 ampere in 0.1 second. If an average EMF of 200 volts is induced, what is the self-inductance of the circuit? Nene madidivalva, ade reciprocation, same problem from the NCERT. The induced EMF is 200 volts. Initial current I1 is 5 ampere. I2 is 0 ampere. What is the self-inductance? L has to be calculated. So again we know, students, E is minus L di by dt. ನೀವಿಲ್ಲಿ ಒಂದು ಏನ್ ಗಮನಿಸಬೇಕಂದ್ರೆ, ಎವ್ರಿ ಪ್ರಾಬ್ಲಮ್ ಐ ಡೋಂಟ್ ಹ್ಯಾವ್ ಯೂನಿಕ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್. ಪ್ರತಿಯೊಂದು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲೂ ನಾನು ಬೇರೆ ಬೇರೆ ಫಾರ್ಮುಲಾಗಳನ್ನು ಯೂಸ್ ಮಾಡ್ತಿಲ್ಲ. ಒನ್ single formula in different forms, that's all. So E equals minus L, this is I2 minus I1 dt. E is given 200 minus L 0 minus 5 divided by, what is the time? 0.1 second. So this is 0.1 or 200. Now this minus and minus becomes plus. This is 5 divided by 0.1, which is 50. So very clearly, L is 200 divided by 50, which is 4 Henry. Again, a very simple calculation. Next one. A jet plane is traveling west at a speed of 1800 kilometers per hour. There is a jet plane which is traveling west at a speed of 1800 kilometers per hour. What is the voltage difference? Andre matpuna he is asking us for induced voltage or induced EMF developed between the ends of the wing, 25 meters long. Voltage between the two ends of the wings. ಏರೋಪ್ಲೇನ್ 2 ವಿಂಗ್ಸ್ ಇರುತ್ತಲ್ವಾ, ಅದರ ಲೆಂತ್ ನ 25 ಮೀಟರ್ಸ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. You will have to calculate the voltage across the ends. If the Earth's magnetic field at that location is 50 into 10 power minus 4 Tesla, dip angle is 30 degrees. How do I relate this problem to what concept? Aeroplane traveling west. Motional EMF. You have studied an expression for motional EMF which says E is equal to B sin theta L into V. BVL ಅಂತ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಓದಿದ್ದೀರಾ? Since the vertical component is given B sin theta L into V, or this is B is 50 into 10 power minus 4, dip angle is 30, sin 30 is half, L is 25, and velocity 1800 into 5 by 18, because 1800 kilometer per hour to be converted to meter per second. So so this goes 25 times. So this is 25 into 25 into 1800 into 5 divided by 18. So the answer is 3 volts. Nearly 3 volts is the answer. See, again, any quantum physics here? No. Just know the expression, solve. The last one, you will work it out as an assignment, but I will give you a hint to solve. A cord solenoid. Again, something to do with solenoid, whose length is 30 centimeter or 0.3 meter, has an area of 25 centimeter square and 500 number of turns. This is not turns per unit length. Simply he says there are 500 turns. So first you have to calculate N, which is capital N by L, which is 500 divided by 0.3. Carries a current of 2.5 amperes. The current is suddenly switched off. That means I2 is 0 in a time interval of milliseconds. What is the average back EMF? Again, EMF has to be calculated across the ends. The same, d phi by dt. Phi is B into A. Now mu is mu naught N by L into I. Proceed with the same method. You will arrive at the answer. So here I complete the session of problems on EMI. Again I say, do practice these problems thoroughly. It will yield results. From tomorrow, again a very important topic, we will start problems on electric current. Until then, be focused, work hard, practice. Have a nice day. Thank you.